In this video, we are going to be doing number 18 on page 141 of the AP Physics textbook. A bag of cement of weight 325 newtons hangs from 3 wires as suggested in the figure. 2 of the wires make angles 60 degrees and 25 degrees with the horizontal. If the system is in equilibrium, find the tensions T1, T2, and T3 in the wires. So here is our drawing. Remember, we always want to draw free body diagrams. So basically, I'm going to be drawing a free body diagram of this point right here. So here we have T1, angle 60 degrees, T2, angle 25 degrees, and then T3 going there. Now, one of the first things we have to realize is in order for the cement bag to not fall down, T3 is going to have to be equal to the weight of the cement. So right off the bat, we know what T3 is. T3 is equal to 325 newtons. It's one of our answers already. This is actually pretty similar to the traffic light problem. We know that the x components of T1 and T2 have to cancel out, or else the cement bag would accelerate in either one of these directions, in the horizontal direction. So T1x is going to be equal to T2x. And we can translate that to T1 cosine of 60 degrees is equal to T2 cosine of 25 degrees. So again, their x components are equal. We always want to plug in numbers as soon as we can, so we can try to avoid algebra mistakes. So 0.5 T1 is equal to 0.9063 T2. Again, I just plugged cosine 60 degrees and cosine 25 degrees into my calculator. Now, in order for this point to stay stationary, the y components added together have to cancel out with T3. So T1y plus T2y will have to equal T3. And we can translate that to T1 sine of 60 degrees plus T2 sine of 25 degrees is equal to 325. Let's put our numbers in. So the sine of 60 degrees is 0.866. And the sine of 25 degrees is 0.4266. Oops, 325. Okay. So again, we have 2 unknowns, T1 and T2, and we have 2 equations. We can utilize a system of equations to solve for T1 and T2. I'm going to do basically the same thing that I did for the traffic light problem. I'm going to solve this guy for T1. So T1 is going to be equal to 0.9063 divided by 0.5, which is 1.8126 T2. And then I am going to plug this into right here. So we should get 0.866 times 1.8126 T2 plus 0.4266 T2 equals 325. Multiply these two together and combine like terms, and you get 1.9923 T2 equals 325. If you solve for T2, you get 163.13 newtons. So we found another one of the things that we want to find. We actually already have an equation for T1. T1 is equal to 1.8126 times T2. So T1 is equal to 1.8126 times 163.13, and you get 295.7 newtons. So we got T3 is 325 newtons, T2 is 163.13 newtons, and T1 is 295.7 newtons.